A model can tell you exactly where a system is. It cannot, from that alone, tell you whether you can move it somewhere else. Observation tells you about the output map, how states translate into measurements. Control authority is about the input map, which state directions your inputs can reach. These are separate structural objects in the system. Models break when one is assumed to imply the other. Knowing where something is does not make you capable of changing it. Observability is characterized by a rank condition on the observability matrix. That matrix is built from the output map and successive powers of the state transition. Controllability is characterized by a rank condition on the controllability matrix. That matrix is built from the input coupling and successive powers of the state transition. These are different matrices with different rank tests. A system can satisfy one rank condition while failing the other. The two properties are structurally independent. The set of states reachable by any sequence of inputs forms a subspace. In a partially controllable system, this subspace is strictly smaller than the full state space. States outside the reachable subspace cannot be reached by any input in any finite time. Knowing the exact current state of the system does not change the boundary of this subspace. Perfect information about what lies outside your reach does not extend your reach. The reachable subspace is a structural property of the system, not a knowledge problem. The separation principle says estimation and control can be designed independently. A good state estimate can be used to drive a controller, and the two designs do not interfere. But the principle only guarantees that the estimate is usable by the controller. It does not guarantee that the controller can reach every state. If the target lies outside the reachable subspace, the controller fails, regardless of how good the estimate is. Full state information is not a substitute for full controllability. The two properties answer different questions. A system with two state variables can have one controllable mode and one uncontrollable mode. The input coupling vector determines which state directions an input can push. A state direction orthogonal to the input coupling is structurally unreachable. Both modes can be fully visible in the output. Both can be observed with perfect accuracy. But observing the uncontrollable mode does not change its controllability. The input cannot reach it regardless of what the output measurement says. Observability and controllability operate on independent dimensions of the system. Consider a fully observable system with a stable attractor and no input channel. An observer with perfect state information can predict every future trajectory exactly. But with no input path, that knowledge provides no leverage. The attractor persists, the system evolves on its own, and observation changes nothing. Prediction and control are not the same capability. A system can be completely known and completely beyond reach. Knowledge and leverage are structurally independent. Each requires its own condition to hold.